Hey everybody, welcome to Tech Tuesday, episode 4. Good to have you. Hey, Bayshore sliding into first. Oh man,
Who's up first?
who's on first? Speaking of, let's start today with our old favorite, a little bit of keep talking. Let's just dive right in. Stand by.
Oh no.
We got it. I fixed it. Don't worry, everybody. This is not our first time doing this.
You should have people submit a 911 Slack if they have an audio drop or something.
Yeah.
Andy,
Post in Slack.
Andy, you can talk about the signal
Yeah.
where you troubleshoot.
Oh, well, that's why we got the comments up. All right, let's do this. Now that I've diffused, 6 modules, 1 strike, 5 minutes.
We're done.
All right,
Keep
let's do
talking,
this.
everyone dies.
Keep talking, and nobody
Keep talking and
gives
the
up.
fish. All right.
Shut up, and no one lives. Okay, I got 5 minutes. I can't see anything yet. Okay, I have wires. Oh, I don't know what this is. It's a lever with something. I have a button, a blue button that says press. I have the words thing. Who's on first, I guess is what it's called.
Yeah.
Symbols
I got
and
who's on first.
Another
How many wires?
Okay,
How many
I have
wires?
2 sets of wires. The first one is 6 wires. Ready for colors?
Go ahead.
Blue, white, yellow, white, black, white.
Okay.
Let me know the name.
You
Or
had
the
another
word.
set of wires you said?
Second set is 6 wires. Black, yellow, red, red, blue, red. Good?
Yep.
All right,
How many batteries?
How many batteries? I have 2 batteries. 2 batteries.
Do you have a lit indicator with the label FRK?
I do not have FRK.
Stand by.
Word in the display.
The display is blank. It's actually blank.
Bottom left.
Bottom left is U, Y-O-U.
SURE.
Yeah, sure. Yes, I have that.
You have that?
Yep.
Go ahead and push that.
Pushed.
Next word.
Andy, cut the 4th wire on both sets.
Okay, hopefully this works. Okay, that one. And 1, 2, 3, 4. All right, we're good on those.
Bentley, hold the button and let me know what color the strip is.
Hold on, I gotta do this needy module thing.
Okay, you're good.
Okay, holding the button and the strip is blue.
Blue strip released when the countdown timer has a 4 in any position.
Perfect timing. All right, Matt, the
Give me that word when you're
display
ready.
is URYOUARE space ARE.
Bottom right.
Bottom right is YOUR. Your
HU
YOUR.
space. Or sorry, UH space UH.
Okay, I have that.
Do you have any
press
other
it.
ones, Andy?
Hold on one second. I have symbols. Matt, the display is C, S-E-E.
I'll do that one. I'm with you, Nate.
Bottom right.
Bottom right is YOU''RE.
Do you have U? YOU.
Yes.
Press it.
YOU. Perfect. We're done with that one. All right. Symbols. Stand by 1 second. Okay. Symbols are. I have the like omega, backwards 6, or like a flat 6, flat top 6. I have the trident thing. I don't know what that's called, and then I have like the funky N with the backwards N with the symbol on top.
Last column, Nate. Is that what you're thinking?
Yeah, that last column. That's what I'm
Did
seeing
you say
as well.
one of them looks like a 6?
Yeah,
Yeah.
6 like a flat top 6.
So 6.
I think it's the 6 first.
The trident.
Uh-huh.
The N.
The N.
Uh-huh.
The backwards N, and then
And
the
then-
omega symbol.
All right.
The Q looking thing.
6, trident, N, omega. Nice.
Look at that.
We did it.
We live to
Boom.
tech another day.
We live to tech another day. Speaking of tech, I got 58 people on. Tech Tuesday. Joe, what are we talking about today?
Oh, I'll tell you. We are talking about signal flow.
Flip the flow.
Flow.
Flip the signal
And
flow.
And the crowd goes wild.
Flip the flow with Joe.
Look, signal flow isn't the flashiest and sexiest topic. It's not like Matt in his bedroom with 6 or 8 lights, and it's definitely not 87 layers of keying on a switcher. But I will tell you this, that I would say the most common issue that we run into on a weekend when we're troubleshooting with campuses and trying to get things up and running is not a bunch of gear that's broken or things that have failed. It's because something isn't plugged in correctly or in the right direction or something like that. So as much as this topic may on the surface kind of seem a little dull, it's a very, very important part of what we do. And it's a great way to help volunteers understand the way our systems are set up.
For real. So what Joe is going to do is he's going to walk us through this concept, and we're going to talk a little bit about some troubleshooting steps and just some ways to think about this idea. And then Justin Wisnant, Zach Kimmery, and Matt Himmler are going to walk through some examples of signal flow in an audio setting, a video setting, and a lighting setting. So I'm excited about it. Let me hand it over to Joe. Why don't you dive in?
Here we go. Tech Tuesday, my friends. All right. So yeah, like I said, gear breaking is typically where I think most people go when they are asked, what's the main problem you encounter? What's the biggest challenge to overcome on a weekend? It's like, oh, if the gear works, or if it breaks, or how to swap it out, or something like that. When like I said, the majority of the issues that we run into is that there's just an issue in the signal flow. So we're going to kind of talk about an overview of what signal flow is and then get into some of those details. So the first thing is just kind of what is it? And so signal flow is the path of a signal from one point to another. It's as simple as that. It's just thinking of how something gets from one place to another. And there are a few terms that we're going to use through the course of this and kind of terminology that is a helpful way for volunteers to think about this process as they're setting up gear or if they're troubleshooting. So our first terminology is source. So the source is what's originating the signal, either audio, video, or lighting, and what is actually creating that signal as it begins down this chain in this pathway. And then of course you have the destination, which is the part where the signal ends, what receives the signal. In the middle of those two things are the next couple terms. One is transmission. Transmission is just the signal going from one point to another along this entire chain. And then of course you have processing, which processing is the alteration of the signal in some capacity, either a conversion from analog to digital in the audio world, or it might be switching from an SDI to an HDMI type, BNC to HDMI type connection. So anyway, the signal is being altered in some capacity. And then upstream, it refers to moving in a direction toward the source, and downstream refers to moving in a direction toward the destination. So a couple concepts to get into your mind as you're thinking through this and as you're training volunteers and things like that, is the idea of value, where you're placing value as you're thinking through all this. Now it's easy to focus just on the gear but essentially every signal starts and ends with a person. And so there's that human factor that I think we often miss. And so in the, an example is you might think mic to speaker, but really what that is actually the signal flow is from the worship leader to the congregation, to the people into the church. And so the value in troubleshooting signal flow and thinking about it is not that the gear isn't working, it's that people are not being able to hear the message or not being able to, worship along or engage with the sermon and things like that. So if you can help your volunteers and help your teams put value in the right spot and ultimately grasp onto the highest value, which is we want our people to be able to see and hear what's going on and be able to receive the message. It's not just about gear working, it's about people being able to engage it with God and everything like that. So that's a high value to have as you're thinking through this. The next one is the idea of just knowing your gear and knowing that certain gear has, different abilities and different limitations. And every piece of gear has a manual and certain settings that have to be configured a specific way in order for your signal flow chain to work properly. And knowing your gear and knowing the limitations can help you through this process of figuring out if something is working or not. So for example, you might have a video converter that can only do 720p or 1080p, but your switcher is designed to work with 1080i, and perhaps you're not getting them to talk to each other, or the image is kind of all garbled and messed up in your switcher and your multi-viewer and you can't figure out what's going on. Well, recognizing that your converter that you're using isn't transmitting a signal that the switcher is able to interpret correctly, or they're not talking to each other with the same language. Knowing those limitations is how you can help better effectively troubleshoot and everything like that. So speaking of troubleshooting, let's get into some of those tips. So there's a few categories that we'll jump through, but the first one, it's very, very complex. No, it's not. Start simple. Start simple. It is so easy, especially when you're working with more complex gear, to just think that the problem is so deeply rooted in the internal configurations. I've got to start unscrewing the face of something and ripping all the wires out because that's ultimately where the problem is. But really, starting simple is actually most likely where your problem is going to occur, especially given some of the circumstances that we are in. So part of starting simple, ensure everything is powered. A lot of the gear that we're talking about needs to be plugged in to effectively work and either transmit or process the signal downstream. So it's an important thing to go through and just make sure everything has power. Next, secure all the connections. Many connectors like a BNC or a PowerCon, they twist to lock in place. And so not every volunteer may know that. They may just plug it straight in like they would a plug into an outlet. And if they just plug a BNC cable straight in and then another volunteer is walking by and they might kick out a cable, they have all of a sudden pulled that connection out a little bit. So it's possible that that's a break in your signal flow. So just making sure that all the connections are secured and then everything is kind of nice and tight. Next, start at the source. So especially in a non-permanent situation, it's very common to have gear set up out of order for what the nature of the signal flow is. So you might have somebody roll a rack in and set that up, and then another volunteer rolls another rack in, or you might have, in our case, the video fly pack with a switcher and everything gets set up before the camera gets set up, but the camera is upstream in the signal flow and it's set up by two different volunteers. And so now, not knowing that everything hasn't been set up in a logical order, it's very easy for something to get missed. So start at the beginning, start at the source, and just work your way all the way down, making sure that everything has power, all those connections are secure, and then everything's plugged into the proper port and that kind of thing. Troubleshooting tips, again, starting simple. Next piece is changing one factor at a time. Part of the goal of this is not just to solve the problem in the moment, but to really be able to follow up with a solution so that it prevents it from happening again in the following weeks. So if you switch 3, 4, 5 things at a time and the problem gets solved, there's no real way to identify exactly what the issue was. So you want to make sure that you're just changing one thing at a time. If you're swapping a power supply or you're swapping a cable, everybody involved in the troubleshooting process, you're making sure that each person is aware of what the process is and that you're working together so that one thing at a time is being switched. And certainly what you also don't want to happen is if you do pull 5 things out at one time and you're replacing 5 new things and the problem is fixed, you now all of a sudden don't want to say it was a bad XLR cable. You certainly don't want that to work its way back into your kit and then all of a sudden get them brought out next week, put back into play, and then all of a sudden doesn't work again. So being able to identify what the exact problem is and then be able to pull that item out for repair and be able to teach your team what was wrong. Next, use gear indicators. So many pieces of gear have helpful little aspects of them that let you know if things are working properly. So there's for example, there's a lot of mini converters that do like HDMI to SDI or vice versa that will have a little light on them that light up when their signal is processing correctly. So, an SDI signal going in, there's an SDI lock light that turns green or red or whatever it is that will let you know the converter's way of telling you I'm receiving that signal. Great. So that's a helpful way to know if, the problem is upstream of you or downstream of you, which is our next piece of identifying a checkpoint. So there's a lot of different things in the chain of a signal flow that you can use to help kind of be a starting point. So one example, like say you can't get a camera to show up on your screens in the auditorium. Now you see that the camera's on and you look in your multi-viewer and the image is there and it's not frozen or anything like that, but you just can't get the switcher to get this thing up on the screen. Well, if you see that in the multi-viewer, that lets you know that everything upstream of that connection is working properly. There's something downstream of that connection. So once you can identify that checkpoint, it will shorten the sequence of troubleshooting and the things that you have to go through in order to, be able to find out what the issue is. So that's a quick overview of our signal flow and some concepts and troubleshooting tips. So now I'm going to throw back to Andy because we're going to show you some examples of what that looks like.
Yeah, that's great. Guys, if you want to turn your video back on, I'm going to have Justin come in and we'll talk about audio first, and let's do some examples of how we can actually use some of those techniques Joe was talking about in a practical signal flow chain to maybe track down an issue. So we have all been messing around with some charting apps. We got a new tool called Lucid Chart that we've been playing around with. That's been pretty fun. So
is that a plug?
A little plug. Just
Okay,
our
cool.
sponsor this week, not a sponsor, but we'll see if we can get them there.
That's funny.
After they see our drawings, maybe we'll get them there. But
Maybe.
Justin, why don't you show us what you got for audio? Give us an example of from a simple to a more complex audio signal flow.
Yeah, let me
source to
see if I can get this
destination.
pulled up. Everybody see that? Can everybody see this right now?
Yep, gotcha.
Cool. It'll work. Do this. Get rid of some lines. All right. So just like Joe was talking about, you also have a source and a destination. So for the sake of what we're doing, I'm kind of going off of, for anybody tuning in, I'm going off of what we would do at a normal non-permanent campus. The only thing that won't be pictured here is an IO rack. Just like Joe was saying, it's either, the speaker, everybody thinks like, oh, it's the microphone or, oh, whatever, but it's really the person or the instrument on stage that is actually the first, is the actual source. So I picked a kick drum, which then we use a Beta 91A as our kick in mic at all of our campuses. So the Beta 91A is sitting inside of the kick. And then from there, XLR goes out and into the stage box. So if you're looking over here, bottom left corner, W2 stage box, this is what most of ours looks like. We have some that are 12 by 4, so 12 inputs by 4 outputs. This one is what that looks like. Some of them are 16 by 4 for the other campuses. And
Justin,
so
scroll
your
up
input,
a little bit so we can see.
Oh.
It's being covered up.
Oh.
There we go.
Gotcha. I see
Cool.
at the bottom. So W2, you would go, XLR would go input into there. And then down here, and I think you can probably see it, the silver part down here is actually a W2 cable, which that line goes back up here, W2 cable into, these are usually panel mounts on our IO rack. And so all it is just a multi-pin cable or connector that has XLRs on the other side of it. So they're input and output that are mirrored to the stage box. And so once the W2 cable goes in there, inside the I/O rack, we have a fan out, an XLR fan out, as you see right here in the middle, goes into our Digico D rack, is what we use at most of our campuses. And so for the campuses that might be tuning in, or anybody else who's tuning in, that like an X32 campus, or we've used Midas before, this would be your equivalent to like a, or we'd be using like an S32, or for Midas, we might be using a DL251. And so input into that, and then it's an EtherCon cable or Ethernet cable. EtherCon has like an XLR sleeve kind of connection around it. And so it's one EtherCon cable out of that D-rack into the back of the SD9. And so then all of your processing happens in the SD9. You can assign it to a channel strip. And then from here, all the magic that's happening in the SD9 is you have a channel strip that is going to an aux output. And your aux output might be going to someone's IEM pack, or it could be going to a monitor wedge, or it could be going to PA. I've picked PA for this instance, and we'll get there in just a minute. But inside the SD9, now you see that there are two EtherCon lines here. At most of our campuses, we have two D-racks. But for the sake of what we're talking about, this one D-rack, it's actually, the signal is coming in that EtherCon cable, and it's going back out the same EtherCon cable to this rack, so the D-rack. And then the output, which I just drew two lines just for the sake of an in and an out. But then you have outputs on the bottom here. And so all that processing is saying, which output are you wanting to send this out? We'll say channel 1. So output 1 is an XLR to an LA4X amp, which we have LA8s, we have DMB amps, like D12s or D6s, but XLR into here, and then out of the LA4X amp would be an NL4 cable that would go up to a line array. I picked Kiva 2 because that's one of our campuses that we've done recently. And so Kiva 2, and then you have little NL4 jumpers that go down here, and your sound comes out when you unmute the amp.
So going back to what Joe was talking about with, of course, we have just our terminology. So we have our source and our destination. So this is a pretty clear example. Our source is kick drum. Our destination is the speakers, in this case, the Kiva 2.
Correct.
Not a sponsor, L-Acoustics yet, but we'll work on them too.
Not a sponsor. Yeah, that's fine.
But what in this signal flow chain, so everything in between, like we said, is either transmission or processing. What pieces, Justin, in this flow are processing, and which ones are just purely transmission?
So, so transmission would be, again, Joe was talking about from one destination to another. So out of the Beta 91 to a stage box, from the stage box to the XLR fan out. So that's all transmission, XLR fan out to the D-rack. Your processing is happening in the SD9, and it's also sending back to your D-rack. The other side of processing is happening in the amp. And I don't know if you can see it on this side. I don't know if it's high enough. But the LA4X amp is actually processing the signal and sending that to the PA. So the PA is just, so basically your SD9 and your LA4X amp are the two processing units in this signal flow. Everything else is just a cable that is signal, and it's based off of what the pins on that cable are doing.
Yeah. So I think a theme that you'll see, that you'll notice, it might be a little bit different with lighting, but especially with audio and video, a theme that you'll see is any of these elements that have processing involved. So in this case, the SD9, the D-rack, the SD9, and the LA4X amp, those are the ones where you can't just necessarily, it's probably going to be a lot more complicated if you can't just unplug and plug stuff in. Like there's usually something going on internally with that. We'll look at video, but an example with video would be the switcher. You know, a lot of times if the issue is at the switcher, you can't just unplug and plug stuff back in. It's not going to matter. If you don't know how to use that gear, then you won't be able to get signal properly from it out to where it needs to go. Everything from the kick drum to the D-rack is just transmission. And so even though it might be changing cable types, like we go from, of course, the Beatty 91A, now that is processing because it's processing the actual audio into a digital or into an electronic signal. But from there, XLR to the W2 stage box, that stage box is just transmission, just a fancy version of transmission. That W2 cable is just a fancy version of transmission, that XLR fan out. And you don't see these a lot of times because they're buried in a rack somewhere. But that's all transmission. So a lot of that would be as simple as just unplugging and plugging something back in. But let's say, Justin, in this example, the kick drum is not getting to the house. What's a checkpoint in this signal flow that we could use to know whether we need to look upstream or downstream from the SD9 to the either closer to the kick drum or to the Kiva? What's a checkpoint that we could use, or a couple checkpoints we could use?
So my normal flow of, and this is really, I do this with audio or video, is I will go and I will see, for audio purposes, if I don't see it metering on the console, I check and see, in my processing, is it the correct input that I have assigned that to on the D-rack? And that's kind of where I start first, is I just start with the SD9. If I don't see signal there, then I just go to the kick drum. I'm like, okay, is there a mic in the kick drum? No. Okay, well, let me put a mic in there because that's probably the issue. The XLR is hanging out.
That's if you don't want to sound dumb, we call that a high impedance air gap.
High impedance air gap.
Just say if somebody asked what the issue was, it's a high impedance air gap.
Yeah. So high impedance air gap. So I usually start at the SD9. If I don't see signal there, then that's kind of like, okay, then I know that nothing is getting to the PA, so I can just eliminate the right side of this graph. And so, I check XLR from the Beta 91 to a stage box, the W2 cable, and I kind of filter my way back to the D-rack, and then making sure the D-rack has the correct input. And then from there, I just make sure that my EtherCon cables are connected. If there's an issue beyond that, then it could be, a broken cable, a broken microphone. So at that point, I might switch out my microphones, because that's probably the thing that's going to break before any of the other stuff in line, before the W2 stage box, before my panel mounts, before the D-rack, unless the D-rack is just not powered on. But those are where I normally check for that side. For the PA side, so if we scroll over, I also just make sure that, again, that the D-rack is connected. So if I see that there's an input, then I know that the D-rack is connected to the SD9 at that point. So then my two failure points would be the XLRs going to the amp, and then from there, the NL4. So if I see meters on my amp, then I know that either the NL4 is not connected to my PA, or or that there's bad NL4, or there's a bad jumper from one box to the next, because you might hear it out of one box, and then I kind of just filter my way down until the bottom, or until I get to my, the break in the chain. So those are the two, break every chain. But yeah, so that's kind of where I start. I usually start at my console for the sake of any of this. Just because I know if I do see signal, then I'm good on the front side. If I don't hear it, then that means something's muted or just not connected to the PA.
Yeah, totally. Matt, let's look at some lighting examples.
Okay. Stop my video there.
Nice. Good
Cool. Yeah. I really I'm thankful that you said break every chain, because
You're welcome. You wanted to say it, but you didn't have.
I did. I totally did. Cool. Well, let's do this. So lighting. All the lamps out there. So I've got 4 levels of kind of lighting systems, going from super simple to a little bit more complex. So level 1, this lighting wiring diagram, your source. So it's a little bit different with lighting. So audio, your source starts on the stage. With lighting, your source actually starts in the tech booth or at front of house. So the source is the lighting console. The source is not the fixtures. DMX does not originate from there.
That is good to know.
So, and yeah, so if you're ever hooking up lighting, or like if you're hooking up audio and then you switch over to lighting, like, just as you're loading in or whatever, you'll notice that inputs and outputs for audio versus lighting is actually, it's opposite. It's backwards of each other. Yeah. It's because the sources are opposite of each other. So we've got level 1 lighting diagram. So we got lighting consoles, the source, single universe, single output. Got your standard 5-pin DMX, or 3-pin. It doesn't have to be 5-pin, but and then your destination is a lighting fixture, single channel, multi-channel. Single channel would be like just a conventional fixture hooked into a dimmer pack, which I probably should have put dimmer pack for a conventional, but
yeah, another day.
And then another day, and then it just continues, and we call those daisy chains. So you can just come in and out, and so on.
I love that.
So, and then we have like a level 2, which is just, it's kind of more the same. It's a multi-universe setup. A typical, so like the reason why the level 1, so Entech makes these really great DMX, like USB DMX boxes. And so I keep like MA like .2 or Onyx version 4.2 or older. They support a free universe. So if you're in a pinch, I would recommend either of those, and those have Entech support. I actually don't know if .2 does, but I'm pretty sure it does. But those are like great in a pinch. Just need something to turn some lights on. That's kind of how we're doing online at Valentine right now, is this laptop single DMX. So level 2, it's more the same. Yeah, all lighting at Valentine.
Just one DMX
is just this. Yep, everything is on the same address.
Challenge accepted.
We just invert to get the circle stuff.
Oh, that's smart. I like that.
Just your basic standard. Yeah, you gotta save those 512 channels. What's that?
Said you're pulling back the curtain, wizard.
Oh yeah. Don't
telling people our secrets.
Yeah, it's just that MA light at front of house is just there's nothing in it.
Yeah, it's off.
So, so then we kind of move on. Level 2 is just more of the same, like I said. Level 3 is when we start getting into. So DMX is a protocol, but it can take a couple of different forms. In the form of just straight DMX, which is 5-pin, or you can use streaming ACN or ArtNet. There's like ClingNet, MANet, ETCNet. Everyone kind of has their own flavor, but it's basically like I don't want to call it digital because DMX stands for digital multiplex, so it's already a digital format, but it's more of a networkable format. So this level 3 would be, instead of doing just a straight 5-pin output, you would use an Ethernet cable to a multi-output node. So this is actually how a lot of our non-permanents, if not all of them, are set up. So we have a console that has, it's usually a PC that has a network output, and then that lands onto we use a Quattro, Pathport Quattro, and then that has 4 outputs. I just put 3, but it has 4. Each output can carry its own universe. So you can have up to 4 separate universes hitting your stage from one cable, which is super nice. I think the tolerance, is like 250 universes down one cable or something or 255, something like that, down one Ethernet cable. So it's a great protocol to kind of get your head wrapped around and implement. And then it just lands single fixture or a single channel fixture, multi-channel fixture, things like that. Then we move on to a level 4. All of the above would work great for like
So many
What?
colors.
Oh, yeah. So the color scheme is more from my own brain. So the thicker green is your 5-pin, the thinner blue is the Ethernet cable, and then or sorry, ArtNet cable, and then the thinner red is just straight Ethernet cable. So it's fine. Don't worry about it. So level 4 would be more of your like permanent installs. So the other, above 3 would work for non-permanents, but this kind of level 4 would be still the same, like network output, multi-channel or multi-universe outputs, things like that. You would actually route Ethernet to like a network switch. So you would want to set up some sort of a lighting network that will receive that ArtNet input and distribute it out across all of these different lines, so to speak. So for your infrastructure, and then those will land on. So you have like single port node, 2-port nodes, just different flavors of nodes. Pathport is a really great one. It's one that we use, and ETC makes some really great nodes as well. But you can also come out. You don't necessarily need a node. A lot of fixtures these days can take raw ArtNet input. So, for instance, for what we use a lot of pixel fixtures. So you can take out of that network switch an Ethernet line to land onto a pixel driver, and that will kick out whatever flavor of cable your pixel fixture needs. But we also have, we have our SL300 movers that will take a raw ArtNet in. Same with like the solo battens that we put at Valentine this week, or for Easter. Those will take a raw ArtNet input also. But single port node, 5-pin, multi-channel out to your rig. And then one thing that you need to consider with like a permanent install is you need to be able to control your fixtures without the console. And so that's where this architectural control unit comes into play. Paradigm is a real popular one. But those also have their own. So you kind of see the network switch comes out, goes into your arch control. That's so your console can talk to it. And then out of that, you land on your dimmer rack. And that is basically so your dimmer rack is able to be controlled by arc control, but you can also basically program your scenes from the console versus within it's just a little bit of convenience factor there. But then you also need to be able to, architectural control, be able to control the dimmer rack independently of the console. So that's where this other Ethernet cable comes in. And typically like Paradigm has, I think it's like 2 universes of output. So you have to be a little bit choosy. Typically it's house lights, key light, something to keep you out of the dark. And then that also has connectors that come out to wall panels. So yeah, I mean, that's kind of a really fast overview of signal flow.
Yeah.
So it starts here.
I did want to point out 2 things. One, go back up to level 3 lighting. Okay. I want y'all to see if you can see some parallels. So remember when Justin was talking about how if you just picture the right side of what Justin was showing us, from the audio console network to the Digico D-Rack to the L-Acoustics amp to the actual boxes, the speakers. Basically, the lighting signal flow path is very similar. We just kind of skip that whole left side of input. Like Matt was saying, the source kind of starts at the lighting console, but you'll notice it still goes to some sort of, in a lot of cases, it still goes to some sort of network distribution system. So in the case of the audio console to the D-Rack, that's network. From the lighting console to the DMX node, whether it's a pathport or whatever, it's network based. And then it goes from that physically to, in the case of audio, it's NL4 to the speakers. In the case of lighting, it's 5-pin DMX to the lights. And then if you'll notice with audio, one thing we didn't necessarily cover with audio, but there are multiple speakers there. That one line array is 8 or 10 or 12 boxes, individual boxes, and they just loop off of each other. And there's only so many you can power from one amp. It's the same idea with lighting, where you go from your DMX node to a lighting fixture, and you can just loop fixtures off of each other. There's only so many you can loop off of one universe.
Right.
But it's the same general idea. Now, in the second thing I wanted to point out in your fourth example, with all the complexity of a permanent campus, you will not, very, very rarely will you dig into this middle section. Because it's a permanent install, we have the flexibility to go a little bit more complex with the setup, because it's not being set up and torn down every week. There's so much more reliability to it just staying set up, so we can go more complex. To try to put something like this, and there are tours and there are things that will get into this complexity, but very rarely in a portable setting would it be smart to put this level of complexity into the platform, because it's just so difficult to troubleshoot this at a certain point. But at a permanent building, a lot of this isn't changing. So when you're troubleshooting issues, if you're in a permanent campus, it's a lot of times not smart to just go right here in the middle and start troubleshooting from there, right? Usually you want to start at the fixture, at the destination, and kind of work backwards. And so we talked about checkpoints in the audio world. What are some checkpoints in the lighting world that we can use, Matt, to see where we might have an issue?
Yeah, nine times out of 10, an issue is coming from DMX in some form or fashion, whether it's a bad cable. So especially like when we're loading in and out of things, cables are like typically the first thing to go. So always reseating connections and swapping cables out is the first thing. So at the fixture, making sure there's a few things that you can do at the fixture that will help you. So one, make sure DMX is indeed connected and it's the proper connection, that it's not like, oh, this is, they plug the cable in, but there's actually two that need to go in and an out. Unless it's the very first one or the very last one, then it's just an input.
Yeah.
But so you want to check cabling. Obviously you want to check power, but you also want to check, most of our fixtures are labeled. You want to check the DMX address and make sure that it matches the patch. So at the fixture, there's right there 3 things that you can confirm: DMX connection, power, and address, and making sure that it's the proper address. Along with the address, just making sure it's in the right mode. Rarely do these things change, but it's just some things to check. And 9 times out of 10, that's going to be your issue. The other thing to do, instead of checking, so confirming that, the other thing with, so like a lot of our campuses are set up in this level 3 area. So we have a node. Nodes will always tell you whether or not they are getting valid DMX. So most of the time, we use the Pathport Quattro, they flash, all 4 flash when they're not receiving a valid DMX. So, checking to make sure power, and then if those are all correct, then checking to make sure that your DMX node is getting a valid DMX.
Yeah.
Before you ever really check cable.
Something else I was going to point out is that your fixtures also have DMX lights. So even if your cables are plugged in, a lot of them will have DMX signal lights that'll blink or turn off if they're not getting valid signal. So you can see, even if the cables are plugged in, you can check if you're actually getting data to that fixture. That way you know to go either upstream or downstream of the signal chain.
Yeah, and that's a good visual, because depending on the fixture you have, sometimes the actual display will flash if it's pointed out. Sometimes they're on opposite sides of the cables on the back, screens on the front. So that's a good indicator too. So that's great. So you can kind of quickly do, and it's all about having valid DMX. You can kind of quickly do a scan of your fixtures and be like, oh, I'm not getting DMX. Well, now you can go, making sure this is connected, but it could be a lighting console issue. So doing a visual check, checking, making sure that there's not something funky with the port. But then you can kind of check the console, make sure. With PC, it could be, ArtNet's shut off or the dongle's not plugged in, something like that.
Yeah, networking is a whole different animal that we should probably get back into that at some point for sure. Networking, because everything's networked now, but there's a lot that can be wrong with that as well.
Talk to everything.
Yeah.
Yep.
Okay, we'll come back to some questions in a minute, but Kimry, you want to give us some video signal flow examples?
Yeah. Man, my document sucks compared to what Justin and Matt just did. I guess video signals flows a little bit more boring.
No, it's fun. Actually, I'll go ahead and point this out. That you'll notice video signal flow is going to be very similar in audio signal flow, because you really do have inputs and you sort of have a brain in the middle, which is it'll be our switcher. But then you also have all kinds of processing involved in between. But I'll let you walk through it, Kimmy.
So the one thing that can be more complex to draw about video, and I struggle with it when I'm doing my drawings because I'm a neat freak, and I'll show you a different drawing in a second that I'm a lot happier with. Videos tends to make you do a lot of circles, especially if you've got a more, well, not even a complex system, but a basic system where anytime you're introducing a video router into play, you can make a lot of circles. If you're not doing a router and you're just using a switcher, then you can kind of bypass the circles. But you can see here we're making some connections, multiple connections to devices back and forth before we actually get truly from source to destination. So here I have picked 3 sources because, just trying to come up with different options. We can start with the first one down here at the bottom, which would be a CG. So from a CG into whatever converter that you have that day, converting it to SDI, and then over and into the router. And then I will stop there and move on. But first, just want to talk about this troubleshoot point right here. This one can get you faster than anything else, because these converters that are taking your computer signal to SDI, they a lot of days do not have a way to tell you that they are getting signal or not. They might not even have a light. If you're using just just your basic standard HDMI to SDI converter. If you're using something more complex like an ROI, you might get lucky, and you can pull it up and see what signal it's getting. Or if you're using, like an Ultra Studio 4K, it'll tell you if it's getting signal or not. However, a basic throwdown converter is not going to give you any indication. So this can be a huge pain point some days, but you always want to just start there, make sure it's got power. I would say 90% of the time they're going to have a light that indicates at least power. May not tell you signal, but it'll show you power.
Yeah, and that's an example of processing. So a lot of people think just that SDI to HDMI converter or whatever is just transmission, but that's actually processing. And a lot of those converters have settings and things that you can change in them, and that's what trips people up. And so that's where knowing your gear is super important. There might be 2 or 3 things that you can do with that converter, and that's all you can do. But if one of those things is wrong, that might be your entire issue. If you don't have time to look up the manual, that's where it's easy just to grab something else, just swap that out. Like Joe was saying, swap out one thing at a time. That'd be one of the first. That's usually one of the first things I start with.
Absolutely, especially the power supplies on them, because they're cheap and they'll fail.
Yeah. Now that's assuming that I've confirmed with my checkpoints that I have in my entire flow, which we'll get to. That's assuming I've confirmed that the issue is not downstream of this, but it's actually here.
And one simple thing a lot of days, especially with non-perm campuses, is the computer needs to be in 1080i, and that's an option click on scaling. The way our systems are built, if they're not in 1080i, it will not work. So that's a huge thing. People will get confused and it won't see it, or it might look like garbage on your screen. That's one of the first things you can check, is that your computer is sending 1080i out to the converter. The next signal is probably the most easiest one, and I put TRIA, but that's just a SDI playout device. So it could be TRIA, it could be a T2, it could be living as one, anything like that. That's just straight SDI, no conversion needed. It's giving you it's got a SDI spigot on it, and then you can take that and go straight into the router. So pretty much on that is it on, and is the cable connected? That's probably the most basic thing to troubleshoot. If you're not getting signal and it's on and the cable's connected, first thing I would start with is the cable. And then if it's not the cable, then it's going to be probably a bigger issue. First thing from there is turn it off and back on. That's silly, and we joke about it all the time, but you'd be surprised the days that turning it off and back on will make it happy again.
For real, start simple.
For sure. We had an issue this past weekend with the T2 here, with TRIA here at Valentine, and turned it off and back on, re-imported the file, and it worked great. So the next signal is probably the most complicated, at least in this. Andy wanted me to go ahead and kind of show this example of how we're doing it in Valentine. So this is our primary online camera, the one that we can drag wherever in the building and patch it in via Synth Fiber and do a segment. We are taking the 2 host mics and actually embedding them into, or we're letting the camera embed the audio signal into the mic. For some of you that have been at our non-perms for a long time, when we started doing return feeds, you know all about embedding the signal into the camera. That's how the audio got into it until we started doing fly packs and embedders. Same exact concept, just taking that feature that pretty much any camera with a XLR input on it will do, and embedding that signal. That signal then transports over Synth Fiber. It could go over SDI if needed, but here with the way we're set up, it's going over fiber, and then it's hitting the CCU. There's a lot of things in this that can train wreck you, especially with dealing with fiber over long runs. A lot of people joke about how much I fuss when I see a dust cap not on a fiber, but it literally will make or break a camera working or not, just with the smallest amount of dust. So that can be a huge troubleshooting tip right there. Most cameras, either the CCU or the ROP will give you fiber levels. So here on the weekend, if Chelsea or Nicole tell me that one of the cameras is not working, a lot of times the first thing I check is the fiber level. And that's easily, with us here, it's easily done on the side of the camera or at the CCU. So check that, and if that's good, then we'll move on to the next thing. But then from the CCU, then we're just SDI into the router.
So something to point out here is in the audio signal flow, and again, kind of comparing back to that because this is the most similar because you have inputs and outputs, you have both sides. You would go right to the Digico D-Rack, and that would go to the audio console. It's a little bit different in video because you sort of have 2 pieces working together, like Zach was saying, especially when you introduce a video router. And so this is where I think a lot of people get tripped up, is this middle section here is between the video router and the switcher. And because a lot of you guys may not have ever seen your video router, may not even interact with a video router, you're going to mainly interact with your switcher. But if signal is not getting somewhere, there's a lot of times where it's actually a video routing issue. But if this causes all this trouble, Zach, what's the benefit of having a video router in line with your video system versus just having the switcher?
For sure. So a lot of times you can easily troubleshoot. So I'm going to use a practical example of here at Valentine. In our equipment room, I've got a monitor in the rack with a router panel in front of it, and I can literally route any source on the router to that monitor right there from in that room, and that is straight off the back of the router. So that gives me a perfect spot to troubleshoot anything. So I can route a video signal there. If it's got embedded audio on it, I can hear it, I can visually see it via the meters on the monitor, and then a router in play gives us and Andy, you can stop me if you want to, but it gives us the ability to route the TRIA, which is the video playback, route it into the switcher, and also route it out to a de-embedder that gets audio signal out to the audio console. If a router wasn't in play, then we might have to route past the TRIA signal through the de-embedder and then into the video switcher, and that introduces even another point of failure. If this de-embedder goes down, then we've lost audio and video signal. If we're doing it this way, then if we lose audio but we still have video, we're pretty certain that it's not the video playout source, and it's also not the cable going to the router. And that helps eliminate several things there of troubleshooting.
So I guess kind of the advantage is with the video router, you can take any input and send it to as many outputs of the video router as you want, right?
Correct.
So I could have one input go to every output of the video router.
Yep, exactly. And I can hop into another example to show that if we would like. So
now let me ask this then. If I can, and you said you can change sources on your video router to a display and master control or whatever. I'm just going to remove elevation, our examples right now. If I was just a small church building a video system, why wouldn't I just use a video router then to feed my screens? And just, if I was just going to switch cameras, why wouldn't I just use a video router to do that?
Because a video router does not do a clean cut. There's no way to do a smooth transition because it's physically changing the signal, and the destination will lose reference when it goes away. So you will see a glitch occur. My mind's blank on the correct term for that right now, but that is what would happen. You would physically see the signal go away. More than likely your projector or your TV would give you the blue screen of no signal, and then it would eventually clock back and it would come back with the new signal.
Gotcha. So there's pros and cons to each. With the video router, you have the pro of flexibility with being able to take your input to however many outputs and change that whenever you want. But with the switcher, you have the reliability. You have less inputs and outputs, but you have more reliability when it comes to switching inputs. And you have what we talked about a couple weeks ago with me and Chris with all your keying functionality and mix effects and stuff like that, cross dissolves. You don't get that with a video router. But now jump into your example with the video router, the other example you were wanting to show.
So with what Andy was meaning, we can take one source and route it to multiple destinations. So we're actually right now, Zach Zolo's down the hallway. We're working on this project today. So we're going from 4 4-channel encoders to 8 4-channel encoders right now. And I have put in place this Ross 34x34 router. And literally for our testing right now, I configured it, and I have gone through and I have taken this first input.
So what's that 34x34?
So that is the video router itself. So that's able to take 34 video inputs, and it's got 34 video outputs, and it's essentially a matrix. We can cross the points to wherever. If we want to send input 1 to input 34, we can, or if we just want to pass it straight through, then we can also do that.
Gotcha.
And then in this instance, with us configuring right now and testing, I have input 1 literally routed to every single output, and then input 1, which is actually being fed from the main router here at Ballantyne, actually has bars and tone going to it. So as we're wiring these new encoders in and configuring channels, we can ensure that we are getting signal to all of them.
Yeah. So you've sort of created a checkpoint for yourself when you're troubleshooting this stuff, where you have, and you'll see this on if you like when we have church at our campuses, we do living as one, and we'll start that event a little bit early. And if you load it early enough, you'll see just color bars and the word elevation church bouncing back and forth. And you'll also hear a tone. That's just like a consistent way for us to send a reliable signal that we know works, so that we know we're not chasing our tail if the issue is somewhere further upstream or downstream. That's sort of a checkpoint that we build in for ourselves to know that we actually are getting signal. But that's great. So what is the advantage of this? So all these video encoders, if y'all don't know, this is basically what's getting Church 2 online right now. Now, what's the advantage of sending one thing to all these different video encoders? What are we trying to accomplish with that?
So with the way things change right now, all of these encoders will not actually be in use. We're going to balance out the workload on some of them, and this gives us the ability to do that. That's why we've added 4 more encoders. The nice thing about putting this router in play is as things change, we can, a perfect example, Sunday morning when we started the 11:30 back up, one of the encoder channels failed and we could not get it back, and they ended up having to rebuild the channel on another device. Well, with the way I was previously feeding it, I had a select few of inputs going to several DA cards. DA cards are distribution amplifiers, and that's taking our cards are 1x4s, and that's taking one signal and splitting it out 4 ways. And so the card that was feeding that was also feeding the production stream. So if this would have happened during the 9:30, because of how we were configured, the production stream would have become a program feed due to obviously the higher priority being church. So this now allows me to have any of these encoders be able to pull from any of these 6 feeds coming, any 4 feeds. There's 2 feeds on there that are always going to be that for internal staff streams things, but that lets me pick off those 4. And then also down here at the bottom, you'll see this thing called a logo inserter, and that's literally a 4 input, 4 output a single channel keyer. So if you can go back to Chris and Andy's video from the other week, you know all about keyers. I'm doing the exact same thing. So I'm able to route one of these inputs through that, insert a bug onto it, and then back into the router and send it to out any channel I want. And the reason for that is a lot of days, I wasn't going to wire it in right now because we're just trying to get the encoders back up, but Nicole wants to do a bug for Throwback Thursday. And she's like, can we just do this downstream in the logo inserter so that it's not buried in any of our captures? Because if we did that bug through the switcher in Valentine, then that would be buried in all of our captures, and we would not have the ability to get that off for future. So if we wanted to use that footage for something else. So doing that allows it to literally only be in the stream going to the encoders going to air.
Yeah. So I'll tell you what, let's do this. And because I wanted to next week pick up on the idea, because we kind of got halfway through video signal flow, but there's a lot more there. And especially this idea of like, I'll present the issue to you guys. What happens if your source and your source is one device, but it needs to go to two different destinations in two different worlds? So the example being, you're doing video playback from a T2 or a computer, and you have one source, it's that device, but then your destination needs to be your video switcher and your audio console. Like, what do you do in that example? And that's where we introduce the idea of embedding and disembedding, kind of the reverse of that idea. So we're going to pick back up next week and finish off the idea of video routing and embedding and disembedding, and we'll do some more talk on that, because I think that's a really important concept that confuses a lot of people, and I want to be able to spend some more time on that. Before we go, any questions from the chat? I want to make sure y'all have a chance to ask some questions. And I always say this, no question is too dumb to ask. I am a big proponent of asking stupid questions. There is no such thing as a stupid question. There are only, I forgot the second part of that statement. But anyway, there's no such thing as a stupid question. There are only stupid people that don't ask questions. I'll say it myself.
Give you an example. I was on staff maybe 3 weeks. No, it was a little bit longer than that. I was mixing monitors at Valentine for the first time this Sunday morning, and I couldn't turn it on. And so I had to go into Master Control and ask Kimry how to turn on the SD 8. I think we have monitors.
Yeah. There's a couple power switches, but yeah, that's good. Rather you ask than not ask.
Yeah, one question in the chat for Ryan about a signal like an ether sound, which in Justin's chart appeared to be two cables, but in actuality it's just one that can do a bidirectional thing at the same time. And so his question is, would signal like ether sound just be considered bidirectional? So I think, Justin, you said you can kind of speak to that. Like when you have a situation where signal is going both directions down one cable,
Mm-hmm.
how do you what's a good way to wrap your head around that from a troubleshooting standpoint?
I mean, think of it as one cable. So if you're getting signal, then that cable is probably not broken on the other side. You're able to send and receive down that same cable. There shouldn't be any reason why you'd be getting signal to the console but not back out. So then at that point, that's where I would go back to my SD9, make sure that my physical routing in the console is actually being sent out. If I know it's being sent out correctly there, then I would go to my DRAC and make sure that the correct output is selected, or the correct output has got an XLR going from that to either my PA or monitor wedge or IM pack or something like that. So again, I just think about it as it's one cable. So if I have signal coming in, then signal will be going back out. There shouldn't be, it's really at that point, it's either on the console or it's on the DRAC. There shouldn't be, because your communication is still happening to and from.
Yeah. Suede, I think that's how you say your name. Would y'all ever do any tech tour for Valentine? And actually, there's been a few videos, and if you look up Living as One on YouTube, they did kind of a post and showed a little bit of behind the scenes. We have done, I think Zach did a couple of Instagram lives. At some point, we should definitely do an official behind-the-scenes production walkthrough. Is anything else like that on YouTube?
Yeah, not while the equipment room looks like a spaghetti junction, but
Yeah, not
once
like
we're
that.
back to
Yeah.
yeah.
We don't do a lot of those live, but partially because we definitely want things to look their best, and there's times when we'll go through transitions and we don't necessarily want people to see our mess. But also there's I get a lot of requests to kind of shadow video control during an experience, and while sometimes we'll allow that, we try to keep distraction out of there, because at the end of the day we have to make sure that our broadcast happens distraction free, and so we try to do as much of that kind of stuff as we can on YouTube for people to watch, and that's why I say Living as One, that one video that they posted was great. They produced it really well. But we'll have to do some sort of Instagram live or some sort of YouTube walkthrough of Valentine, the behind the scenes stuff. Jeremy was asking how we like Lucid Chart. You guys like it so far? I seem to like it better than Google. Well, definitely better than Google Slides or Google Drawings.
Yeah,
it's got stuff
sure.
built in to be able to do the
I
connections. That's the big thing, is the connections portion of it.
Yeah, I think also just knowing the other, like, there's a lot better softwares out there, but they're so much more expensive, and this is a pretty, what seems to be fairly cheap, software that we're using, and you can collaborate with your team pretty easily, and it's, again, fairly inexpensive. So I think for what it is, can't beat it.
Not a sponsor, but if anybody from Lucid Chart
Another
is
plug.
watching, give us a shout.
Hey,
Get that enterprise account.
Take some comp licenses.
Yeah, I'll plug some.
Yes.
I'll plug some stuff. I'm not afraid. I don't know if we have any. I don't know if there's any
We-
limitations about that. I think we can do that. I don't know.
hey, Andy, can you get a switcher next week and just
Yeah.
overlay
I'll throw some keys
across the
up
screen,
there.
just Lucid Chart?
At least it's sponsored by.
Tech Tuesday brought to you by Lucid Chart.
Look at those sponsors. If anybody out there is from any manufacturers, you want to sponsor us, let me know. We'll take it. We'll take Clinton's question last. If we put it, I know Joe, you kind of answered this, but do you put any sort of redundancy, cabling wise, or do you simply make provisions in your systems for fallback in the event something fails? Justin, what would you say on redundancy? I have some thoughts on it, but you kind of design the systems.
Not really. I mean, we do have like backup plans, I guess, for like, so biggest example that I can think of right now is SD9. So we actually have a multi Ethernet cable that is just one big cable that has 6 Ethernet cables running through it that go to front of house, and it also goes to our IO rack at our non-permanents. So if one of those cables inside breaks, it doesn't break the other ones, but if you have enough of them go down, then you got to have a backup plan to get your signal back and forth, but either between the D-racks, or if Matt wasn't doing, if Matt needed a backup for his lighting stuff, that if, whatever happens, wireless DMX fails, then what we actually have is we send extra cables with people. So I guess that's kind of our redundancy. It's not true redundant because you can't just flip a switch and it works. So from a non-permanent standpoint, it's just sending extra cable for people and saying like, hey, this is the same link. This is just your backup. But from, a permanent standpoint, I feel like Valentine probably has more redundancy than we do, as far as like having UPSs or whatever in place to keep power going. We just don't have, we try to keep things cheap as possible, but not suffer, or not let like our experience suffer at the cost of like being like, oh, well, we've got to do it as cheap as possible. So we do send extra cables, but that's probably our only true redundant thing that we do.
Yeah, and for that kind of stuff, it's more likely you're going to discover that in setup.
Right.
And then when it comes to like redundant gear, stuff that would fail mid-experience, a lot of times it's not cost effective to just throw another piece of gear at it. It's like, yeah, we could have a backup lighting console, a backup audio console, backup switcher for everything, but that'd be so expensive so fast, and the likelihood of that stuff going down is so low. We have a backup plan for it, but it might not be putting that gear back in place. It might be, rolling an acoustic worship set, or one of the eKids audio consoles in there and doing an acoustic set. If it's the sermon, our Living as One or whatever encoder or decoder we're using at that point goes down, we have a video file that's pre-recorded that they can play back from the night before, that kind of stuff. So we have, I think redundant plans are important to have in place. Redundant gear comes down to priority and cost, and so sometimes it just comes down to it's not cost effective to do it for the likelihood it would go down.
I would say too, we just switched over to another system that we're going to start using at Concord, and we could have bought a whole nother unit to basically use all the control for like all the TVs, turning them on and off by just clicking one little button, or sending audio the way we want to. But our kind of plan was like, well, you can have a remote and go turn the TVs on or off.
Yeah.
So if the system goes down, it's not truly broken. You can still get signal back and forth. It's just, you can't, it's not as easy. You got to go to each individual TV and turn them on or off, stuff like that. So we had to weigh out those costs where it's like, yeah, we can give you the free remote to go turn your TVs on or off, instead of spending, double the price just in case something happens.
Yeah, you get your
and it's like on my side of it with us, it's like, yes, money's still a factor, but I spent extra money for this router that we just put in to get the redundant power supply, something we would never do at another campus. But that router is literally feeding online church right now. So if that went down because I didn't spend an extra $1,000 on a power supply, is like, that would be a pit in my stomach for a mistake. Whereas like, that's not necessarily needed. And I mean, don't get me wrong, the router at a other location failing is still a big deal. Like, that's is still a very big issue. But you're right, Justin, we could go to acoustic and it's all isolated into the room and the campus pastor could preach. But when we're talking about feeding online church and that goes down, that there is no backup to it. And you're right. I mean, as far as we go, like redundancies, like you can't have a spare switcher sitting here, but it is sitting on a battery backup. That's about as far as, it can go. If there's a redundant option, then we've got it, but we don't have another switcher and we sure don't have another router sitting on the shelf. But it's those there are certain risks and there's certain things that you're never going to be able to make redundant. And that's just the nature of the game that we're in. It's like, this is broadcast equipment and it's eventually going to fail. And when it fails, it's probably going to hurt really bad, but there's no way around it. Some things just can't be redundant.
And some of what we do, and that's part of the reason why we've chosen to invest in quality gear and stuff that doesn't fail very often, because in all honesty, it's probably less expensive to buy the little higher quality gear than two of the less expensive one. So being willing to invest a little bit more into something that won't fail, because for us on Sundays, there are campuses a couple states away. We're not driving them a projector if there's fails. So like Andy said, we've got a backup plan for them, but we've tried to resource them with quality gear.
And the one thing that I can say, since we're on like troubleshooting earlier, like if your gear, there's a lot of gear that does have two power supplies and it doesn't need to, it's just free redundancy. Check and make sure that you're working. If it's got an indicator, like check and see that you've got both indicators. I will openly admit that we screwed ourselves at Blakeney before we moved out of Blakeney by not checking the power supplies, and because one of them burned up, and then when the other one finally failed, it took us down. And it's one of those things we could have checked. So it's like, if your gear doesn't give feedback via computer or software like that, check indicator lights and that type of thing. It seems silly, and it's probably one of those things that's a true pain to go and do, but it could save you a lot of headache for just a simple walkthrough.
All the audio all the Digico stuff has redundant power supplies for that reason. A lot of times that's the first thing to go, or the most likely thing in gear to go. And so manufacturers do pretty good about building redundancy into their gear as well, making it more reliable, but there's always that chance. And like I said, if it's not backup gear, it's a backup plan. I like to say, we try not to say what if, we try not to ask what if, but in the production environment, that question can be your best friend, to just play that out and say, what if this were to happen today? Well, then I guess we either would have to stop, it would shut everything down, and we can decide if that's worth it or not, or if if this happens, then we'll go to an acoustic set, or if this happens, then we'll go to our backup file. But that's okay. Just knowing what your backup plan is still good. It doesn't have to be ideal, but it has to be something. You have to have something. Yeah.
I think also to go back to kind of what Joe was saying is like we also get gear that's kind of we try to get in the same family of gear. So try the same company that may have a power supply that works for another piece of gear, that might be replaceable. And so, you might say, what is this, is this other thing more important than the router? No, it's not really that much more important. The router is actually what's making church happen, because that's all of our input and output. So, taking something from one piece of gear and saying like, they don't need this monitor for this weekend. Let's get an IEC to go into this, this other piece of gear. And let's just say, hey, this is what is most important, not a talkback monitor or a clock monitor or whatever it may be.
Sure.
So that's one
good.
thing that I've always tried to like tell, campuses is like, make sure that the most important thing is getting powered on and working and troubleshot first, instead of worrying about something that maybe no one else notices.
Super true. I'll answer one more question from Jaron. What does your morning checklist look like to make sure you're not troubleshooting signal flow issues mid-service? Real quick, we do full run through the worship experience. Hopefully we don't have issues that we're troubleshooting during that, but honestly, that sometimes is our chance to get all the issues out. And then, we check our stream every morning before we do run through on Sunday mornings, where we go up and check Pastor Stephen's mic, we check all the band, we make sure that's all getting in place, and that happens before run through. But sometimes it's just, if you can't solve an issue, it is troubleshooting during run through. If we haven't figured out something by the time the experience is supposed to start, we have to have a backup plan in place. Again, going back to backup plans, we kind of have to give up on that and figure out what's our alternative for that. It's not necessarily a good idea to be continuing to troubleshoot something and depending on something to work right in the middle of an experience.
And along with that, like placing value on what the item is that you're troubleshooting. Like if you're troubleshooting the signal from the broadcast campus, you do that until the last possible minute, because that sermon is the most important part of what we do.
Yeah.
But if you have like a microphone that's not working, if you're troubleshooting that for 2.5 hours, it's like just cut it, use a backup mic, grab a wired mic if you have to, but like you kind of place value where you should, and not bang your head against the wall for 2 hours on something that could be fairly inconsequential given the larger picture.
But but we don't have enough.
Keep the main thing the main thing.
Keep the main thing the main thing. But beyond that, we don't have a ton. Every production director has their own process to check in the morning their stuff, but a lot of that stuff's just built in, a little over 117. It was a good conversation. I'm glad we got to talk about it. Any of y'all want to add anything, subtract anything, multiply or divide anything, echo anything,
square root something?
I'm sure I will want to retract something if I watch this back, but
yeah, I want to retract that. I told everyone that I
say
asked.
That. We did good. Didn't have to censor it.
All right, well, we will see you guys next week. Remember, we're going to talk about audio, this concept of embedding and disembedding. But until then, we hope you guys have an awesome week. We'll see you. If you don't know, hopefully we'll see you in Video Control, Valentine Video Control. Subscribe to the Elevation Production channel on YouTube, and you'll see when that goes live at the 9:30 experience.
Man, you sound like a blogger right now. You're
he
like,
does.
I'm going
Get it.
full, I'm going full
Click the
YouTube.
bell.
Hit that like,
As a
smash
host on
subscribe,
online.
click the bell for notifications, and we'll
Where's
see you
graphics?
guys. We'll see you guys next week. Bye.
Hit him with a noggin.
Lucid chart.
Noggin.